Hi everyone, my name is Benjamin, and in today's video I will show you how you can send a bundle of transactions to the Jito block engine using the Solana Vibe Station send bundle RPC method. So we are going to talk about how to use this tip-based service and land transactions atomically, what the benefits are of using Jito and sending transactions in a bundle, and eventually how we can apply this when buying an actual token. And on top of that, all the code will be available for download via our GitHub repository. For more information, you can always visit our official documentation or join our great Discord community. Both links will be in the description, and I'll hope to see you there. And with that said, let's get started. Alright, let's have a brief look at the actual documentation, and this you can find by going to docs.solanavibestation.com, and then under API docs you will see Jito, and here you can find more information about the send bundle RPC method. The first thing that you see is that we will have to use a staked RPC to consume this method. We will have the tip address, so this is the address that we will have to send the tip to, so we will have to create a tip instruction in one of our transactions, and then we can find a bit more information about this RPC method and also the requirements. You can find an example on how you can create a post request and what information you get back once it's succeeded or fails. So this will be really interesting for us once we are going to implement it into our code, and we will for sure get back at this. Alright, so before we jump into the actual code examples, let's have a look at what these Jito bundles actually are. So Jito bundles are a feature provided by Jito Labs that enables ordered and atomic execution of multiple transactions on the Solana blockchain. And we can send these transactions via the send bundle RPC method that we just looked at. So what is this send bundle RPC method exactly? As we saw before, this method allows us to submit these Jito bundles to the Jito block engine via our staked RPC tiers. And there are a few requirements, of course. We can send a maximum of 4 transactions per bundle, and a tip will be included, and the tip minimum needs to be 0.001 SOL. And the instruction for that tip needs to be presented in the last transaction within our bundle. All the transactions within that bundle needs to be base 64 encoded, and again the transactions are executed atomically and in the order that we provided. So why should we use these bundles? Now, they provide us with MEF protection, meaning that our transactions are routed through the Jito's block engine, preventing front-running or sandwich attacks. And that means that they cannot reorder, include, or exclude any transactions from our bundle in that block. And the atomic execution, as I said before, all transactions in the bundle either execute successfully altogether or not at all. And the guaranteed ordering, of course, the transactions they execute in the exact order that we provide them in or that we order them in, and this avoids issues with random validator ordering, of course. And finally, we also have a higher inclusion probability. As this is a tipping service, we can provide a tip to directly incentivize validators to include our bundle in the next block. So in short, this service reduces exposure to external actors trying to reorder or interfere with our transactions, and we get the ordering and atomic guarantees, at least for the bundle that we submit. We don't know what happens before or after that bundle, and of course we also have the freedom to incentivize these validators to include our transactions in the next block. So how do these Jito bundles work? So we will create and sign multiple transactions. We will make sure that a tip instruction is added within the last transaction, and then we will bundle all these transactions together, and all these transactions, they need to be base 64, of course. And then we will send that bundle to the Jito block engine via the send bundle RPC method, and then the block engine forwards these bundles to the validators. So what are some use cases to use these Jito bundles? Now there are a few examples here, and they are not limited to just that. And MEF arbitrage is one example, and this is a specific type of MEF strategy, and it focuses on exploiting, and I believe a better word here is capitalizing on price differences between decentralized exchanges for the same token pair. For example, we can buy it cheap on one DEX and selling it high on another DEX within the same block. founder buys, for example, we can combine the token creation, the liquidity initialization, and the first buy into the token into a single atomic bundle. And this means that it ensures that all the transactions are executed together in one block, preventing front running or snipers during the launch of our token, and it guarantees a fair and secure execution. And of course, there are more complex operations that we can bundle to, for example, handle transaction size and compute budget limits by bundling all these instructions across multiple atomic transactions. So now that we looked at some actual use cases and we know what the Jito bundles are, what the requirements are, and how to set it up, it's time to look at some code examples on how we can implement this and use it for ourselves using the send bundle RPC method from Solana Vibe Station. Alright, so I'm here in my code editor, and as a reminder, all the code will be available for you via our GitHub repository. And if you look at the package.json file, you will see that we can start the script by running npm run start, and that in turn will start the index.ts file. So if you have a look at this file, what we do here is of course import some classes that we need, like for example the Jito Center class that we created, and we will have a look at that in a minute. We initialize our .env config because that we will use to store some sensitive data, and this is for example the staked RPC and also the staked RPC URL with Jito with our API key of course, and also the private key that we will use to derive a key pair from, that we will use to send the transaction but also sign the transaction and make sure that we can send the tip with the bundle. So if we go back to the index file, after we initialize the .env config, we can access these variables via process.env, and then these variables here that we specified in that env file, and then we will store them within these constants here so they are accessible for us throughout the script. Then we have some functionalities, and if you scroll all the way down, you will see that we initialize the Jito sender first. And once that is successfully, then we will start one of these functions here, and we will have a look at all of them, where we will buy a token and also buy and sell it in one transaction, and also send some transactions including a memo. So we will have a look at all of these, but the first thing that we will always have to do is make sure that our Jito sender class is initialized, and we can do that by triggering the init Jito sender function. And what this will do is store a instance of the Jito sender class that we created and store it into this Jito sender constant. And then we can use this Jito sender constant throughout all the functions here to make sure that we can talk to this class that we created. The only thing that we need to provide is this staked RPC URL and also the staked RPC URL to make sure that we can send the bundles. Now, once this is successful, it will return that instance, and then we will store it. And if everything goes well, we will return true. And if everything goes through and is successful, we will trigger the buy pump swap functionality. But let's have a look at our Jito sender class first, which we imported here on top and is stored in the Jito sender.ts file. And here you can see that we have a class called Jito sender, and this class holds some private variables, like for example a RPC connection both for version 1, which is Web3GS version 1, which we will use to talk to the pump swap SDK, but we will also have an example using the Solana kit, which is also rebranded from Web3GS version 2, and also the key pair that we derive from this private key that we stored here in that environment file. We will have some Jito settings like the Jito tip, the tip address, and the maximum number of transactions that we want to create, and we also have some variables to store our pump AMM SDK and the internal SDKs, and also the fee program and the fee config public keys. Now, once we create an instance of this Jito sender class, the constructor will be triggered, and here we initialize all these variables. So we will create an actual connection using Web3GS version 1 called connection, and we will do the same for the Solana kit, and that we do by using the function create Solana RPC. And here we provide the RPC URLs that we provide, and we store also the Jito URL to make sure that we can also send these transactions. We create a key pair again from that private key, and we initialize both pump SDKs, the online pump SDK and the pump AMM SDK, and then we store it within the private variables that we declared here earlier. And then we will just log out that we initialized this class successfully and that we are using this RPC and this Jito RPC URLs. And once we have that class initialized, we have access to all these functions here, like for example the buy pump swap, buy and sell pump swap, and the send functionality. Alright, so back to our index.ts file, and now that we triggered the init Jito sender function, we know that we have a instance of this Jito sender class that we just looked at stored into this Jito sender constant. And now we can use this constant to access all these functionalities that live within this class that we just created. And that is what we are going to do next. So once this is initialized properly, the next function will be triggered, and that is called buy pump swap. And of course, later we will also look at the buy and sell pump swap and the send function. But let's have a look at this first function here called buy pump swap. The first thing that we will do is make sure that the Jito sender is set and that it is initialized. If not, then we will return false and do nothing. Otherwise, what we will do is take that Jito sender instance or that instance from that class that we created and then access this function or this method here called buy pump swap. And the only thing that we need to do is provide the pool key from the token which we want to buy. And I just took a random pool key from a token on GMGN. And this is the token that we are going to buy. It's called FTP. So what we will need to do is take the pool key, of course, because the pool key is needed to actually perform the swaps using the pump SDK. So if we have a look at this buy pump swap functionality, again, it lives within the Jito sender class, and we initialized this class, and then we have access to this functionality here. So if we look at that, the only thing that we will need is that pool key, and we will provide it and check if it is a string. And if it is a string, then we will turn it into a public key. And the next thing that we will do is set the tip receiver, and the tip receiver is a variable that we set earlier in our class here. So if we look up, here is the tip address, and that tip address, remember, we can find within the documentation here. So back to our code, this is the tip address, and we will create a public key for that. And the next thing that we will do is create a swap state, and that we can do by using the pump AMM internal SDK, and they provide us with a method swap Solana state where we provide the pool address and also the user public key. And remember, the user public key is derived from the private key here, which was set once we created this class instance, because then the constructor was triggered, and here we created that user or that key pair from that secret key that was stored in our environment file. So that is why we have access to this user's public key. The next thing that we will do is take this swap state and create these swap instructions, and we can do that by using the pump AMM SDK, and then we have access to the method buy quote input, where we will provide the swap state and also the amount of lamp ports in a big number format, and we will provide the slippage. And then we have the swap instructions, and we will add some additional keys. And for these swap instructions, we also need to add the fee config and the fee program, and these are also here on top specified. We have the public keys for both of these, the fee config and the fee program, and then we add it to the swap instructions. The next thing that we need to do is create a tip instruction, because remember, for one of our transactions that we will add to this bundle, we will need to add a tip instruction, and that we do by using the system program transfer method. And here we can say we want to tip from the public key, so our user that we created, the tip receiver, which we also created here on top. We have the public key for that, and also the lamp ports of the Jito tip, and the Jito tip we also specified here on top. And we will tip this service with 0.001 Solana. And then we have these tip instructions here, and then we can also later add these to our transactions. The next thing that we will do is create these transactions based on these swap instructions that we created, and we will create, of course, two transactions, and we will call it transaction 1 and transaction 2. The next thing that we will do is get the most recent block hash, and that we can do by accessing our RPC version 1 and use the get latest block hash method, and that will return us the block hash. And then we will finalize these transactions. So we will take transaction 1, add the recent block hash, add the fee payer, and then we will sign this transaction, and then we will turn this transaction into a base 64 format. Because remember, if we look back at the documentation, it says here that all the transactions must be base 64 encoded. We also finalize the second transaction, but also here we will add that tip. Remember, we created that tip instruction, and we need to add that tip instruction to the last transaction within our bundle, and that's what we do here. So for transaction 2, we add the tip instruction, and then what we will do is send the actual bundle using the send bundle method. And if we go back to our documentation, we have that example here. And what we do is copy this exact example, and we are using Axios. And Axios is just a fancy fetch library, you can say. And we are going to do a post request to that RPC Jito. So this is the RPC URL /Jito. And we use the method send bundle, and we provide the transactions here that we created earlier, transaction 1 and transaction 2. And of course, we need to provide all the parameters as was set in the documentation. The next thing that we will do is extract the data and then the result, and then we stir that into a signature. And this will return to us all the signatures from that bundle that we submit. And if we take the first signature and we try to confirm it, because remember, these are executed atomically. So if the first signature is successful, that means that all the other transactions within that bundle are also successful. If this is successful, we will return the confirmation. However, if there is an error, that means that all our transactions did not go through, and then we will also throw an error. However, if it was successful, then we will just return that first signature, and we will also output all the signatures. So now that we have set up this, what we can do is just run this. And remember, in our index.ts file, we trigger the initialization of our class, and then we trigger the buy pump swap functionality. And this will in turn trigger this buy pump swap function. If we go to PowerShell, what we will do now is npm run start. And if we start this, this will initialize that class that we created, and then it will send these two transactions in one bundle or that token that we specified. And if we have a look at that token now, you can see that we bought it here. And if we click on that, that should show us the actual, you can see here the transactions, and these are our two transactions. So if we click on this real quick right now, you can see in SolScan that this was confirmed, and this is the block. So if we copy this address, because this is our public key, and we go to this block here, and we would then filter by the address that we used, we should see these both transactions, as you can see here. So these were both of our transfers or both of our transactions that we created, and they were executed within the same block. So that means, or that confirms actually, that this worked. All right, so knowing that the first example worked, what we can do now is do the exact same thing, but this time we are going to buy the token and sell the token. And earlier in the video, I talked about strategies that we can do, like for example, the MEF arbitrage strategy, where we buy a token on one DEX and sell it on another DEX, and there we capitalize on the price differences between these two DEXs. Now, to find a real arbitrage opportunity, that is outside the scope of this video, but we can mimic it in a way by buying the token and selling the token within the same block. And that's what we will do here. So if we go back to the index file, and now we will use the buy and sell pump swap function, and then we will replace it. So we are exactly going to do the same thing. Initialize our Jito sender, and then trigger this function here called buy and sell pump swap. And what we will do is look at this function real quick. So this function will do the exact same thing. It will take the pool address, set the tip recipient, create a swap state, and then we will create two transactions or two set of instructions, one to buy and one to sell. And this time we will specify the amount of tokens instead of the SOL, because we want to make sure that we buy and sell the same amount of tokens, and we don't have to rely on the Solana price or the amount of Solana. Next, for both of these instructions, we are going to add the fee config and the fee program, just as what we did before, and then we will create these transactions, providing it the instructions. We will also create the tip transfer again, same thing as we did before, system program transfer, and then we get the block hash. Once again, we finalize the transactions. Also here within the second transaction, which is our sell transaction, we will add that tip instruction. We turn them into base 64 transactions, and also here we will use the same approach, and we are going to send the buy and sell transaction using the send bundle method. And we need to make sure that we first buy and then sell. And also here we will confirm it by taking the first signature, and if it worked, that means that also the second transaction went through. So what we can do now is start this once again by typing npm run start, and that should initialize our Jito sender and also send that bundle, and here we get back the actual transaction. And if we have a look at that, also here you will see that it is finalized, and we can once again copy this address, go to that block, and then if we sort it once again by the address that we just used, you will see that we have two transactions here, a transfer and a sell. And if we go back to the token, you can also see that here that we bought and sold this token in the same block, and also that we can see here. If we click on this, and then we have to specify, of course, our own wallet, you can see here that we bought and sold this token. And of course, this was earlier, 1 hour ago, where we bought it twice, and then just now we bought and sold it. So that is also working using the bundle strategy, where we can buy and sell the token in one block using a bundle. And of course, this is a simplified example, but in a strategy, for example, a MEF arbitrage strategy, you would do the exact same thing, but you would buy and sell across different dexes, of course. However, I hope you understand the example that I wanted to show here, that you don't only have to buy the tokens, but you can also buy and swap them back in one transaction, or in one bundle, better, within the same block. Alright, so back to our code editor, I will show you one more example. So if we go back to the index.ts file and we swap the buy and sell pump function for the send function here. And if we have a look at that, we will take the same approach. We will use the Jito sender, and then we will use the send method. If we have a look at this method, this one is built using the Solana Kit functionality. So we're using Web3.js version 2. And what we will do here is, of course, create a key pair once again, and we will derive it from that private key. Now this might look strange because, as I said, we are using Solana Kit and not Web3.js version 1. But again, all the code will be available, so if you want to play around with that, or you can also check the Solana cookbook. There the documentation will also cover the differences between Web3.js version 1 and Solana Kit. However, what we do here is create a key pair from that private key, and then we will create a signer from that key pair that we created here. And also here we will extract the latest block hash, and this time we are going to use the RPC version 2. And this is the RPC connection that we set up using the Solana Kit. So it's the equivalent of the connection from Web3.js version 1. And also here we can consume the method called getLatestBlockHash, and that will return to us the latest block hash. We will create a tip receiver, and this time we will use address and not public key. And then we are going to create these transactions. And the amount of transactions that we will create is specified in the Jito number transactions, and this was set to 4, if you remember, in the private variables that we set here earlier. So we are going to create 4 transactions, and we do that by looping through or creating an array based on these 4 transactions that we want. And the first thing that we will do is check if this is the last transaction. So if this equals to 4, then we will also provide it the tip receiver, because only at the last transaction we want to add the instruction to pay the tip. And what we will do here is build the transaction using the build transaction function, and that function is declared here below, and we can have a look at that. So it will take the index, the latest block hash, the payer signer, and if this transaction includes a tip. And what we will do here first is create a memo instruction using the getAddMemo instruction function, and also all this comes with the Solana Kit library. And we will add a memo saying Solana Vibe Station transaction 1, 2, 3, or 4 of 4 transactions in total. And then we will create a transaction by piping all these instructions into this constant called transaction message. And here you can see that we specify a signer, the latest block hash, the memo that we created, and also adding a tip only if the include tip is set to true. And remember, this is only true if it is the last transaction. So we use this functionality to create all these transactions by setting or creating an array based on the number of transactions that we want to create. And then they are stored in the signed transactions constant. And then this signed transactions constant, we will map through and turn all these transactions into base 64 encoded transactions. Because remember also here, if we are using Solana Kit or Web3.js version 1, we need to provide these transactions in base 64 format. And then we will do the exact same thing. We are going to provide these transactions that we created here earlier and turned into base 64 format, provide it to our call that we will make using Axios to our RPC Jito endpoint, and we will of course again use the method sendBundle. And what we will do here now is the exact same thing. We will take that signature and return it. And if we go back to our console and we clear it real quick, what we can do here now is type npm run start, and this will send these transactions in one bundle for us. And as you can see, now it returns to us 4 transactions. And if we look at the first one, if we go back to Solscan and we would search for this transaction, you can see that it was finalized, that it was confirmed. And also here we can copy the public key again, go to that block, and once again filter by this address. And here you will see that all these transactions landed within that same block ending with 22. And if we have a closer look at these transactions, you will see that they have a memo saying Solana Vibe Station 1 of 4. This will have Solana Vibe Station 2 of 4, Solana Vibe Station 3 of 4, and the last one should have 4 of 4 and also include that tip instruction. As you can see here, we sent that tip of the amount 0.001 SOL. So these were 3 examples to show you how you can use this send bundle method or this send bundle RPC method. Again, there are many use cases and the code will be available for you so you can play around with it, test it yourself. I hope you think this was interesting. If so, like the video, subscribe to the channel because a lot more content is coming your way. And with that said, that's it for today and I hope to see you in the next one.